Hey, how's it going?
Oh, hey, where have you been?
Oh, I've been fixing leaks. Man, this experiment is driving me nuts. There's leaks everywhere.
This has been a constant source of headache.
Well, at least it's different than yesterday. Yesterday I was a baker. Today I'm a plumber. Variety is the spice of life.
Just because you baked out a vacuum chamber doesn't make you a baker. What's next, candlestick maker? You could 3D print those. What project are you doing the plumbing for?
Yeah, it's called HaICU. I thought it was one of those Japanese poems in the beginning, but those don't leak.
Well, sometimes the readers do. I wonder what they're doing over there.
Well, put on your beat cop hat. Let's go find out.
Well, I see you've got your Snoopy coat on, so let's go.
Beat Cop and Snoopy asked me to narrate this piece as it may be less cringy than what they had planned. I'm supposed to read out a haiku for haiku. A haiku is a short-form poem with a specific structure, 3 lines with a 5-7-5 syllable pattern. Here is what they came up with. Off our heroes went to unlock haiku's secrets. Wow, they are awesome. They wanted me to emphasize the words our heroes, but I just couldn't do that. I think the last line in their poem should be, wow, they are so dumb.
What the? Cut!
Hey, Chuckman.
Hello.
What are you working on?
I'm working on the HaICU silicon PM detector chamber. So this thing is how we're using silicon PM to detect hydrogen atoms. The details are pretty boring. We have a laser that excites the hydrogen atom, and the atom will de-excite and emit photons again. And this guy detects those photons in order to prove that there's actually stuff in the vacuum chamber.
Okay. Do you mind if I ask about your professional background before you started working at TRIUMF?
Yeah, I am an applied physicist. And I got my PhD at Berkeley like more than 10 years ago. Actually, just 10 years ago. Yeah, my advisors were Jonathan Worsley and Joe Fagans. Believe it or not, I used to be a theorist. Yeah, I got my PhD working on simulating non-neutral plasma in a panning trap. But after I got my PhD, I found that working on hardware seems a lot more interesting. So that's why I'm here.
That makes sense. And Chuckman, what experiments are you involved in at TRIUMF?
I'm involved in both Alpha and HaICU. So this is a hardware setup for HaICU, but Alpha has a setup at CERN, which is like studying antihydrogen.
Okay. And what are the objectives of HaICU and Alpha?
Okay, so Alpha, the Alpha experiment mainly synthesizes and traps antihydrogen atom and measure their physical properties in order to compare those with the properties of hydrogen. And the ultimate goal is to verify whether there's any difference in physical property between matter and antimatter, which is like one of the fundamental questions of our universe. HaICU the aim is kind of a front runner to alpha. So alpha has been studying antihydrogen atoms in a magnetic minimum trap that is powered by superconducting magnets. But the superconducting magnet has quite a lot of limitations in that it produces a lot of field. But the cryostat, which is the cooling system for the magnet, is very complex. And that means it's very difficult to have additional access to the anti-atoms once they're inside. What HaICU is doing is trying to develop alternative methods to produce and study antihydrogen atoms. Obviously, here at TRIUMF, we don't have antimatter. So what we are doing for now is to use hydrogen instead of antihydrogen. But we are doing everything in a way that is compatible with antimatter, so that we can eventually translate the methods developed here to study antihydrogen.
And what, in your experience, has most prepared you for this role?
So like I said, I began as a theorist, but I think in the role as an applied scientist, one never get used to what you're doing because everything is new. Most things no one has done before. So what would one do to prepare for something like this is just be curious and patient. And my training in physics taught me the rules and theories to apply for a specific situation, and that's just you just need to know when to apply it and what kind of approximations you need to make in order to squeeze your actual system into a theory into the theory.
What's the most important thing you've learned at TRIUMF?
The power of project management, I suppose. So Nicola has helped HaICU with a lot of project management, which is part of your group. And yeah, he's really done a lot for us. And it's kind of a different side of doing science rather than doing math and calculating or simulating or assembling. What Nicola does is something different. It's like putting all the pieces together and making sure the rules are followed, and the parts arrive at the right time. Components can talk to each other. They agree. They're designed to work with each other. So it's very different from what I used to do, and which is theory, or what I recently do, which is designing hardware. So yeah.
What are some of the unique challenges you've encountered in your experiments?
Well, much like building anything, I think accessing enough resources is always a challenge because there's only so much to go around. For HaICU, we need a lot of electricity and water, and getting those can sometimes be a challenge. So in particular, HaICU requires cooling water for the magnets on the order of 10 liters per second. So you can imagine it's pretty big quantity of water. And so to get that water to us requires laying pipes and designing modifying the existing cooling system at TRIUMF to provide that water to us. And given everything else that's going on around the lab, finding the resources to construct and design and construct that cooling system has been challenging. And the same for electricity. The electromagnets in HaICU requires a lot of power, a lot of just current.
What annoys you about your project?
One thing that has been a constant annoyance is broken plumbing. Our experiment needs a lot of water. There's a lot of very heavy plumbing, and we're really not good at it. So we keep on breaking fittings, water leaking everywhere, making a huge mess. So that's been annoying.
As we always ask, what's a tune that's been stuck in your head?
Do you know what a Vocaloid is?
No.
It's a human speech synthesizer, but one that's capable of tune. So people use it as basically a musical instrument that emulates human singing. There's a whole subculture in Japan that writes songs using Vocaloid software, and there are many different versions, each with a very specific voice.
And do you make your own music using?
I tried many years ago. The software itself is capable of singing, but usually for a very good composition, people are expected to do a lot of post-processing. Without the post-processing, the singing sounds really robotic and not very nice at all.
Ouch. I hope that bush is okay.